Alright everybody, welcome back. We're going to look here. This is our second video on section 10 from unit 2 of AP Calculus, finding the derivatives of the tangent, cotangent, secant, and or cosecant functions. And in the last video we developed all the derivative rules that we need for these various functions, and in this one we're just going to go ahead and work our way through a few examples and look at some things that can help us along the way when we're finding these derivatives and some of the issues that might come up. Alright, so let's pick right up here with example 2. Find the derivatives of each of the following. So first we start with f of x equals 2 cosecant of x plus the natural log of x times cotangent of x. And again, we're just building and building and building these rules on top of one another, so we need to continue to apply the rules that we already know. So here we go. Derivative of the left side is f prime of x, and on the right side we've got a constant multiple 2 times the derivative of the cosecant of x, which is opposite of cosecant of x, cotangent of x. And then to take the derivative of the natural log of x times the cotangent of x, we're going to have to use the product rule. So we've got natural log of x times the derivative of cotangent of x, which is negative cosecant squared of x, plus cotangent of x times the derivative of the natural log of x, which is 1 over x. And I'm just going to go ahead and clean this up and, bring constants and negative signs to the front of each term. And this turns into negative 2 cosecant of x cotangent of x minus natural log of x cosecant squared of x plus cotangent of x over x. And there's not really any simplification that we can do beyond this, at least not anything meaningful, and so we're going to go ahead and stop right there. Alright, up next, part B. Find the derivative of g of x, where g of x is the tangent of x minus 2 all over secant of x. Make sure you're aware here that the way this is notated, this is the x is inside the tangent, but the minus 2 is not. If I wanted to write the tangent of the quantity x minus 2, I would certainly use parentheses in order to do that. This is, again, the importance of parentheses. Since I've written this, how do you know what it represents? Well, I've written it using correct notation. And so make sure you know that this and this are not the same. Alright, so we're going to go ahead now and take the derivative. G prime of x is equal to, and I'm going to use the quotient rule here. So I've got low d high, so secant of x times the derivative of the tangent of x, and the derivative of the tangent of x is secant squared of x minus high d low, and the derivative of secant of x is secant of x tangent of x. Square the bottom, and away you go. And so I'm all done with the calculus in this problem. Now I'm just going to do some algebra and see if that gets me anywhere from a simplification standpoint. So I'm going to go ahead and multiply out all these terms in the numerator. The denominator is pretty well set for us. Multiply all these things out. So secant of x times secant squared of x is secant to the third of x. And then I'm going to go ahead and distribute. And so I've got a negative sign times the tangent times the secant of x tangent of x, which when I multiply all those together gives me negative secant of x tangent squared of x. And then I'm going to do the same, and I'm going to multiply the negative sign and the minus 2 and the secant of x tangent of x, and so that becomes plus 2 secant of x tangent of x. Something you'll notice when you look at this numerator is that all of the terms contain a secant of x, and so I can factor a secant of x out of everything in the numerator. Gives me secant of x times the quantity secant squared of x minus tangent squared of x plus 2 tangent of x. Okay. All of that over secant squared, and so I can now take this secant of x with one of these secant of x's from the denominator and eliminate those. And so this turns into secant squared of x minus tangent squared of x plus 2 tangent of x all over secant of x. And there's our derivative. All right, let's go on to the next page. And we're going to do part B again. And I said here, the easy way this time, which, kind of sends up a signal flare for us. Gosh, we just used the quotient rule. How could we have made it, any easier for us? And really what I can do is I can rewrite g of x first and separate it into these two parts. The tangent of x minus 2 is sine of x over cosine of x minus 2, and dividing by the secant is the same as multiplying by the 1 over the cosine, or pardon me, dividing by the secant is the same as multiplying by the cosine, since cosine and secant are reciprocals. I misspoke there. And now I can go ahead and simplify this, and I get that g of x is really just equal to the sine of x minus 2 cosine of x. And now I can take the derivative of that, and that's a whole lot easier than using the quotient rule. We end up with a derivative of g prime of x equals cosine of x plus 2 sine of x, which is vastly different, from the answer that we found in part B the first time. If you remember, that was a whole lot more complicated. It was secant squared of x minus tangent squared of x plus 2 tangent of x all over secant of x. Yikes. The question now is, are these the same? And we're always kind of running into it, some kind of, uncertainty as far as how much we can simplify our answers when we're taking trig derivatives. So let's, take a look at this derivative that we found on the first time we ran through this problem and see if we can't get it to be equal to the derivative that we got the second time. Well, the first thing that I'm going to do is there's a little Pythagorean identity, which if you don't know it, it wouldn't be hard to find or wouldn't be hard to develop. Secant squared of x is equal to the quantity tangent squared of x plus 1. And so this is equal to tangent squared of x plus 1 which turns our solution into 1 plus 2 tangent of x all over secant of x. And then, of course, I can do kind of similar to what I did here. I can turn this into 1 plus 2 sine of x over cosine of x. That whole quantity times cosine of x. Can distribute the cosine through. And boom, I get to the exact same derivative. Now, which of those derivatives do you think is nicer? And were we better off using the quotient rule or simplifying first? In this case, we were better off simplifying first. And in fact, that's what you see next here. Be on the lookout for easier approaches than just blindly applying rules. Realize sometimes you may simplify differently from someone else. There's a lot of different options when you're dealing with trig functions. This would have been, if you had done the problem like we did on the previous page, that would have totally been an acceptable answer to me, because I'm not looking for your simplification and your knowledge of trig identities. I'm looking for your calculus work. So keep that in mind. But we'd like to take the easier path when it's available for us. All right, a few more examples here. Let's go ahead and we'll slam through these really quick. Part A, y equals x to the fourth times the secant of x. There's not really anything that we can do to make that simpler, so I'm just going to go ahead and start applying my derivative rules. Y prime is equal to, and we're going to use the product rule. So we've got x to the fourth times the derivative of secant of x, which is secant of x tangent of x, plus secant of x times the derivative of x to the fourth, which is 4x to the third. So y prime is equal to x to the fourth secant of x tangent of x plus 4x to the third secant of x. And I'd like to go ahead and factor out the greatest common factor from both of these terms. And so I'm going to do that. I've mentioned before, and I feel like I should mention again since it's still fairly early in the course, in general, I always like to factor things if I can, because a factored form of the derivative is usually a better form for our use. All right, now part B is one of those where we'd really warn you, don't use the quotient rule on this. Rewrite this first. This is equal to 8/3 times sine of x. And so when you find the derivative of it, it's just going to be the constant multiple 8/3 times the derivative of sine of x. And boom, I'm done. Okay? Don't take the time to use the quotient rule on that and then try to simplify it when you can make it much easier to start with and get the derivative. I mean, this is a really nice, neat, easy-looking derivative, and we did it very quickly and very easily. All right, y equals secant of x over the tangent of x plus 1. I'm going to warn you, these two problems in C and D look very similar to one another. Secant of x over tangent of x plus 1 versus secant of x plus 1 over tangent of x. In one of these, it's going to be better for us to try and simplify it, and in the other one, it's not. The one where tangent of x is in the denominator is the one that's going to be better, because anytime you have a single term in the denominator, it's going to be easier to simplify versus having multiple terms in the denominator. So we'll go ahead and take the derivative of this one, and we'll use the quotient rule. So we've got low d high minus high d low, square the bottom, and away you go. And then we'll go ahead and distribute. And that gives us secant of x tangent squared of x plus secant of x tangent of x minus secant cubed of x all over tangent of x plus 1 quantity squared. And then I'm going to factor secant out of everything. So we've got secant times the quantity tangent squared of x plus tangent of x minus secant squared of x all over the quantity tangent of x plus 1 quantity squared. And I could really stop there, but again, this is fairly similar. We have a trig identity. Tangent squared of x minus secant squared of x is equal to -1. And so I can simplify this to secant squared times tangent of x minus 1 all over the quantity tangent of x plus 1 quantity squared. Okay, now this one is easier if we simplify first. Let's make it 1 over cosine of x plus 1 times the reciprocal of the tangent, so that's going to be cosine over sine. And so if we simplify this first, we've got y equals 1 over sine of x plus cosine over sine of x, okay, which is equal to cosecant of x plus cotangent of x, and then we take the derivative. Derivative of cosecant is negative cosecant cotangent. Derivative of cotangent is negative cosecant squared, and then I'm going to go ahead and factor a negative cosecant of x out of both of these. And boom, I'm finished. And that was undoubtedly easier than it would have been to find that derivative using the quotient rule. All right, everybody, got a lot into that video. We're all done with section 10, and hence we're done with unit 2 of the course. See you next time when we start unit 3. Have a great rest of your day and enjoy yourself.